Okay, guys, so we're going to look at the chain rule today. Chain rules used for complex functions. This is the doodle notes in case you missed class. I'm trying to go through what we talked about. So when do you need the chain rule? So up here I said, do I need the chain rule? So I'm going to say no, I don't need the chain rule. So here's an example, y equals 3x plus 1. I don't need the chain rule. Yes, if this was y equals 3x plus 1, that quantity, to the fifth power, I would need the chain rule. If I have y equals the square root of x, I don't need the chain rule. If I have y equals the square root of x squared minus 2x, I need the chain rule. Y equals sine of x, I don't need the chain rule. We have a basic rule for that. But if I have y equals sine of 8x, I need the chain rule. Y equals 3 over x plus 1. I don't need the chain rule. Y equals 3 over the square root of x plus 1. There I would need the chain rule. So I use the chain rule when I have very complex functions, what we call composite functions. So like we're going to look at each of these and kind of decide what am I talking about this composite function. So the next thing, we're going to look at a function, and it's going to have two parts. It's going to have what we call an outside function and an inside function. So let's just start with this first one, the y equals 3x plus 1 to the fifth. So the outside function of that would be this fifth power. It's whatever the outside. So it's usually the power or the square root. Sine and cosine trig ones are a little bit different, but the outside function of that is the fifth. So that's the outside function. The inside is 3x plus 1. Sometimes I call that the baby, the inside. I know it's weird, but that's how I thought of it. So that's why I'd say that. Here, if we have this function, the square root of x squared minus 2x, the outside function is the square root. So the outside is the square root. Inside is x squared minus 2x. Kind of get the idea that the outside is the outside. The inside is the inside. The sine of 8x. This one's a little bit different. The outside function is actually the sine. The inside function is the angle 8x. And today we're not going to actually do any with sine and cosine or trig functions. I'm going to save that for the next day. We're going to make them separate. What if I have, well, this one's kind of weird. I don't know if I have enough space for this. X plus 1 over x minus 3 squared. So the outside function is the squared function. The inside function is that x plus 1 over x minus 3. And this one is special because we are going to use the chain rule, which we're going to learn, and the quotient rule. So that's kind of a special one. Let's do one with the product rule and chain rule. So let's say I have x squared times the square root of 2x minus 1. So this one, really, the chain rule is only going to get used on this part because it has an outside and an inside. The x squared is just going to be part of the product rule. So here, my outside function, the only part I'd use the chain rule is what I circled. So the outside function would be the square root, and the inside function would be that 2x minus 1. So let's go down here. The chain rule basically is a composite function. So it says if you have f of g of x, so you have two functions, one is inside, one is outside. To take the derivative, you take the derivative of the f, you keep the g, you keep the baby, the inside, and then you multiply by the derivative of the g. So it becomes a chain because you do something in a pattern. So it's the derivative of this outside function, and you keep the inside. That's what I call the baby. And then you multiply that answer by the derivative of the inside. Remember we had our basic power rule. So like if you have, let's just call this u in here, u to the n, that would be n times u to the n minus 1 multiplied by the derivative of u. So I'm going to put multiplied by du, so that stands just by the derivative. These say the exact same thing. I just wrote them in two different ways to see if we could kind of understand what those meant. All right, so let's try one. I'm going to do a couple of these. I also need to do one. I'll show you one that where we move it. So let's start with just that 3x plus 1 to the 5th. So y equals 3x plus 1 to the 5th. So I do the outside function, which is the 5th power. So the derivative of y with respect to x is going to be 5. So that 5 comes in front. I keep the inside, 3x plus 1. And I do my power rule. So that 5 comes in front. So the derivative of that then makes that 4. So that's the first part. I did this part right here. Now I have to multiply by the derivative of g, what's inside. So what's the derivative of the inside? I'm going to multiply by 3. So my answer is 15. And I got 15 because I multiplied 5 times 3. So 15 times the quantity 3x plus 1 to the 4th. That's the derivative. Technically, I could have started with this and FOILed 5 times to get that as well, but this was much easier. All right, let's try another one. Let's do this one. Let's do the square root of x squared minus 2x, and I'm going to try to take the derivative of that. So what we need to remember is that this square root is the 1/2 power. So just remember that this is the same as 1/2 power. Now we're going to do this. So we bring the 1/2 in front because that's the outside function. So I have 1/2 times the inside. And I still do my power rule. So 1/2 minus 1 is negative 1/2 multiplied by the inside. I need the derivative of the inside. So the derivative of that would be 2x minus 2. Now it gets a little funky. Not really funky, but you just got to remember this is negative. So I'm going to bring that to the bottom. This is the base. So that's going to go to the denominator. This is already in the denominator. So then it looks like 2x minus 2. This piece is in the numerator over 2 times x squared minus 2x to the 1/2. And because I just made this problem up, I see something else that can happen here. This has a 2, this has a 2, this has a 2, so we can actually cancel all of them. And we get 1x, or x, minus 1 over x squared minus 2x to the 1/2. And that would be your derivative. We're not going to do sine and cosine today, so I'm going to try a different one. This is one that you might see. Let's say this. Let's say we got 4 over 2x minus 1 to the 4th. I guess 4 is my favorite number today. So this is a new type of problem. It looks like a quotient rule, but it's really not. What you need to do is you need to rewrite this one as 4. So that's this 4. We're going to bring this whole thing up to the numerator. We're going to rewrite it as 2x minus 1. And when I bring it up there, it's to the negative 4th. So now I'm going to do the power rule and the chain rule. So I'm going to start with the power, which is my outside power. So it's negative 4. I'm going to take negative 4 times this 4, which is going to give me negative 16 times 2x minus 1. And then my power rule says that I subtract 1. So negative 4 minus 1 is negative 5. And then I need to take the derivative of the inside right here. So the derivative of that inside would be just 2. And now I'm going to simplify. This whole thing is the base with a negative power, so it's going to go in the denominator. I'm going to take this negative 16 times 2, so I'm going to get negative 32 over 2x minus 1 to the 5th. That would be how we would do that. You can do that with lots of different problems. Like if you had like 5 over the square root of x plus 1, you could rewrite that as 5 times x plus 1 to the negative 1/2, because I would bring it up to the numerator. So this is negative, and then the square root is 1/2. And then you can do the chain rule, the power and chain rule from there. So the chain rule is like an addition to the other rules, and it just makes it, sometimes it actually makes it easier to find a derivative. But it makes it so we can find the derivatives of composite functions, so like a function within a function. So like this is a linear function inside a square root, is what that is. That's a composite function inside a rational function. They're all composites. Okay, let's find one where I'd have to use the, well, let's do the one like this. They always seem to show up. So let's say we have x plus 1 over x minus 3. Let's do to the 4th power. We're going to find the derivative of this. It looks gross. It actually usually simplifies okay. So the outside function is the power of 4. So the first thing you do is you move that 4 in front. So 4 times x plus 1 over x minus 3 to the 3rd. That's the first part. It wasn't too bad. Now we have to multiply by the derivative of the inside, the baby. So the problem is the derivative of the inside is going to require the quotient rule. So I'm using brackets, and you're going to see why. I'm not going to do anything with this piece right yet. I'm just going to do my quotient rule. So quotient rule says the derivative of the top, which would be 1 times x minus 3 times the bottom, minus the derivative of the bottom, which is 1 times x plus 1, all over x minus 3 squared. So now you have a bunch of algebra to do. So if I do this, this is going to give me x. It's going to give me negative 3 minus x minus 1. So if I simplify this, so you take your time to do that, I think the x's are going to cancel. I'm going to have negative 3 minus 1, so I'm just going to have negative 4. So this piece gives me negative 4 over x minus 3 squared. This outside in the green, which was that first part of the power rule, sorry, my hands are fat on the screen, is 4 times x plus 1 over x minus 3 cubed. Now the question is, can I simplify this? And yes, well, hopefully you were asking that question. I'm sure you don't want to, but yes, you can. First, this 4 and this negative 4 are coefficients, so let's multiply them. So we get negative 16. The numerator has x plus 1 cubed. I'm just going to write it x plus 1 cubed. The denominator, notice this is x minus 3, this is x minus 3. This one is to the 3rd, this one is to the 2nd. When you're multiplying monomials with their exponents, you add. Same thing with this binomial. So this is going to become x minus 3 to the 5th. That is your answer. Okay. Let's try one more. Like I said, this is kind of the basic one. I know we'd all like to do those, but I want to make sure I show you the harder ones too. Let's do, shoot, how about x squared times the square root of 2x minus 1. So this problem, we're going to use the product rule and the chain rule and the power rule. We're just going to use all the rules together. So let's start with the product rule, because that looks like we need to do that first because there's two terms. So the derivative of x squared is 2x. I keep this thing, 2x minus 1, the square root of that, plus x squared. Now when I take the derivative of this, this is where I'm going to have to use the chain rule. So remember, this is 1/2 power. So I get 1/2 times 2x minus 1 to the negative 1/2. So that's the power rule. Now I need the derivative of the inside. So the derivative of the inside is 2. Again, the calculus is done right there. Now it's just a bunch of algebra that you don't like to do. I'm going to just leave this term for a minute just because it looks nice how it is for a second. And this term here, this whole thing can go to the denominator because it's to the negative 1/2. I see a 2 in the numerator and a 2 in the denominator, so I'm just going to cancel those guys right now. So I end up with this x squared, that stays in the numerator because it's positive, over the square root, or however you want to write that, if you want to write it as 2x minus 1 to the negative 1/2. My pin's doing the fun thing again. Okay, so yes, that's not the negative 1/2. This would be the positive 1/2. Forget what I said there. When I bring it down, it's positive. All right, so I'm going to show you the butterfly with this, just so you can get used to it. If I put this over 1 and I multiply, this 2x is just going to stay 2x. When you multiply this, square root of 2x minus 1 times the square root of 2x minus 1, you just get 2x minus 1. So that's what I get when I did this diagonal. When I multiply this diagonal, I get plus x squared all over the square root of 2x minus 1. And then I can simplify that again. This gives me 4x squared minus 2x right there. So then 4x squared plus x squared, so I get 5x squared minus 2x all over the square root of 2x minus 1. I'm not sure on your assignment today if they're written in this form or they're written in this form before we did that. We'll have to just look at them. All right, so that's kind of an overview of the chain rule. Try the practice, see what you can do.